You have an envelope in front of you there that says confidential on the front of it. What is in that envelope?
It's a paper that's under embargo because the world thinks it's going to be very important. And it's going to be a lead article in the Frontiers in Science because this is a strategy to manage cancer effectively. And we have a lot of evidence to keep these people alive a hell of a lot longer. We have given hope to the hopeless.
And you have a perspective on treating cancer and other metabolic diseases that others don't have.
Yes, but the problem is the field doesn't understand what I'm saying about the origin of cancer. So everything comes back to mitochondria. And all chronic diseases and cancer are the result of damage to this. And the science is telling us this, but the field of cancer has yet to accept it. That is a tragedy.
Are you pissed off about this?
Well, who wouldn't be? There's 1,700 people a day in this country dying from cancer. That's 70 an hour. And it gets worse every single year. When is the people going to wake up?
So give me a prescription of how I should live my life to keep my mitochondria healthy.
So it all comes down to what you do to maintain the health and vitality of the mitochondria that reduce the risk. But we are now in a new environment where we have massive amounts of highly processed carbohydrates, inactivity, emotional stress, poor sleep habits, and you chronically damage this organelle. And then if you look at the domestic dog, cancer is the #1 killer of the domestic dog. But wolves in the wild rarely have cancer. But the wolf is out running around eating natural foods, yet the dog is in an apartment somewhere, gets a dog walker once a day, right? And the next thing, the dog is obese and full of cancer.
And I want to give people actionable things that they can think about.
So this is what's really important. This is a bioenergetic roadmap to health. This is what we call the zone of prevention. It's very hard to get cancer or chronic diseases when you're in these zones.
So let's talk about that.
So
this is super interesting to me. My team give me this report to show me how many of you that watch this show subscribe. And some of you have told us, according to this, that you are unsubscribed from the channel randomly. So favor to ask all of you, please could you check right now if you've hit the subscribe button, if you are a regular viewer of the show and you like what we do here. We're approaching quite a significant landmark on this show in terms of a subscriber number. So if there was one simple free thing that you could do to help us, my team, everyone here, to keep this show free, to keep it improving year over year and week over week, it is just to hit that subscribe button and to double check if you've hit it. Only thing I'll ever ask of you. Do we have a deal? If you do it, I'll tell you what I'll do. I'll make sure every single week, every single month, we fight harder and harder and harder and harder to bring you the guests and conversations that you want to hear. I've stayed true to that promise since the very beginning of the Diary of a CEO, and I will not let you down. Please help us. Really appreciate it. Let's get on with the show. Professor Thomas Seyfried. What is it that you've committed your life to doing, Thomas?
Well, we're right now committed our lives to managing cancer effectively without toxicity, which is based on the science that I and others have done in this field.
You have a perspective on treating cancer and other metabolic diseases that others don't have. The mainstream, should I say?
Oh, yeah. Well, mainstream doesn't have it for sure. But it's based on science. I mean, my work is based on what Otto Warburg, the famous German scientist, said from the 1920s, 30s, and 40s. He clearly showed that cancer was a mitochondrial metabolic disease.
What does that mean, mitochondrial metabolic disease?
Okay, it means that the origin of the disease resides in the organelle called the mitochondrion. It's in the cytoplasm of the cell. It used to be called, still is, the powerhouse of the cell. It gives the cell the energy.
I think we have a mitochondria. Could one of my team bring in a mitochondria?
Well, you have a mitochondrion here. Oh, here we go.
You've got one each here.
Yeah, well, see, this is the little organelle that you see. It looks like a bean shape, but it's actually a tubular network. These are tubes, and they respond dynamically inside the cell to both internal activities as well as external activities. So you have to realize that at the time of conception, all of the mitochondria for the developing embryo are in the cytoplasm from the mother.
The cytoplasm.
The mitochondria are not in the nucleus. They're in the cytosol.
Oh, outside of it.
Outside of the nucleus, but in the cell body itself. So all of the mitochondria, they determine our destiny. They will determine how long you will live on the planet if you don't have an unfortunate accident or something like this. They have an expiration date. Different species die at different times. You don't find people living 400 years. Mice live about 2.5 years. Elephants live, as long as we do or whatever. But that's all determined by this organelle. So you can see I have wrinkles and this kind of thing. This is from living on the planet. And this is from wear and tear on this organelle, which allows us to make energy efficiently. So when this organelle starts to falter with age, you die. You die from old age. This organelle has to be protected and respected if you would like to live a normal lifespan. But in diets and lifestyles and way we are today, we damage this organelle. And this organelle then can present itself damage to this organelle, which is a tubular network inside the cell. But let me say something else. It not only controls the internal environment of the cell, it also controls the neighboring cells, the liver neighborhood, the lung neighborhood, the colon neighborhood, the brain neighborhood, the glial neighborhood, the neuron neighborhood, but they all come from the same origin in that cytoplasm. And they determine the overall metabolic health of your body. It's a systemic. They communicate with each other across cells, across tissues. I'll tell you, this organelle controls a lot of what that nucleus does. It tells the cell when to divide. It tells the cell when to slow down.
It's kind of like a brain, but also like an engine room.
It's kind of like that. Certainly, the brain part of it is really mysterious in the sense of how it controls the destiny of the cell in the body.
So sickness, disease, cancer. What do we know about the role that this little thing plays in these chronic diseases and illnesses and cancers that so many people suffer with?
Yeah, well, this is the organelle that becomes damaged, and it can be damaged in many, many different ways. For cancer is what we have spent a lot of our time on, and now we've moved into the whole chronic disease issue because each chronic disease can have different manifestations of ill health to the mitochondria in a particular population of cells. But in the case of cancer, which is what we call the most serious of the chronic diseases, creating the most trauma, the most emotional distress. But we have clearly shown, based on many, many works, that any multiple things from our environment can damage this organelle in a particular population of cells in a particular organ. For example, when you talk about carcinogens, it's a chemical that causes cancer. How does that chemical cause cancer? It damages the proteins and the lipids. These little squiggles are delicate internal membranes. They contain the proteins and the lipids that allows us to generate energy when we breathe. Okay, you're breathing, I'm breathing. I take in oxygen. Oxygen serves as a final acceptor for electrons that allows ATP to come out of this little, and don't forget it's a tubular network.
And ATP is the energy currency.
It's the chemical energy currency. It allows enzymes to work. It allows all the metabolic machinery inside of a cell to work optimally.
So just to play this back to you so I know I'm clear, oxygen comes in because I breathe in. I then eat food. In that mitochondria, it does a process and it spits out ATP as the energy.
Well, and the waste products of a good energy metabolism would be CO2 and water. So when we burn gasoline in an engine of a car, we break down the octane, the carbon-hydrogen bonds in an octane, and we have an internal explosion that drives pistons. Okay, the exhaust is a lot of waste products from breaking down. We're doing the same thing inside the cell. We're combusting carbon-hydrogen bonds. And that combustion of carbon-hydrogen bonds is a graded process. So it's not an immediate explosion. You're breaking down the carbon-hydrogen bonds in a very precise way, producing ATP, which then drives the entire machinery of the neurons and the rest of the body. Mm-hmm. It can respond dramatically to energetic stress, emotional stress. Anyway, I gave you an example of a carcinogen. Intermittent hypoxia, like people who have sleep apnea, they stop breathing for 30 seconds or more in that general. And then that creates ROS. And that's what carcinogens do, ROS. These are called reactive oxygen species. They damage those delicate membranes. And then what happens if it's too acute, too stressful, the whole cell will die. The cell loses its energy and we get apoptosis or necrosis and cell death. But if it's gradual, chronic, over years, months, years, this organelle loses its ability to produce sufficient energy, but the cell compensates interestingly enough, by using these ancient pathways, heirlooms of our evolutionary past. So, because all life on the planet evolved in oxygen, without oxygen in the dark, these cells grew like crazy. There were single cells, they were unbridled proliferation and all this kind of stuff. They didn't have mitochondria. They had bacteria. And the bacteria, which this organelle came from, was a fusion between one cell that had a nucleus and was fermenting through the cytoplasm. And this bacteria, which is the mitochondria, came in. And now you have two different forms of energy. You have the energy in the cytoplasm, the ancient fermentation, and then you have this new form which can take in oxygen and generate energy much, much more efficiently than the heirloomic. Listen, one of our big discoveries, if you can believe it. But you see that space in the middle there?
Yeah.
That's called the matrix. And that's where the Krebs cycle, the TCA cycle, which breaks down the food that we eat. But they have an ancient part of a fermentation mechanism inside, because before oxygen came, all life forms were fermenters. They produced energy without oxygen because there was no oxygen. We had to wait for those bacteria to make oxygen through a photosynthetic process. But all organisms were fermenters in the beginning. After this organelle came in and was able to take in oxygen, make energy really, really quick. But in that matrix they have, in the cycle, there's a little pathway there that makes energy without oxygen from the evolutionary past. So we have it in the cytoplasm of the cell because they can ferment in the cytoplasm. But our big discovery, with the work of Christos Chounopoulos from Semmelweis University, he's the world leader on that little pathway. When this organelle becomes impaired, these ancient pathways of energy through fermentation arise. Okay, they try to replace the lost energy from the efficiency of this organelle. That space starts throwing out ATP from glutamine. It's another fermentation fuel, and it's making ancient energy in the sophisticated organelle that evolved to make efficient energy. So let me tell you. So you asked me, what about damaging this organelle and what happens if the damage to oxidative phosphorylation,
what does that mean?
Which means energy through oxygen, is too acute, the cell will die. Cyanide is a perfect example of this. You take a mouse or a rat or a person and you drink Kool-Aid, the cyanide-laced Kool-Aid, you die. Because what happens is that cyanide binds to the protein that's going to use oxygen for energy. And the whole system shuts down.
Like suffocates you, basically.
Yeah, you die instantly. And there are other things that can kill quickly, azide and a variety of the chemicals. But for chronic diseases, it's usually not an acute stress on this organelle. It's a chronic stress. And in cancer, what happens in a particular tissue, whether it's bone, lung, bladder, brain, they gradually compensate with these ancient fermentation pathways. So this organelle signals to the nucleus, I'm suffocating, I'm not getting enough energy. So the nucleus turns on the transporters on the surface of the cell to bring in fuels that will elevate energy through what we call oxygen-independent mechanisms. This is an oxygen-dependent organelle. This gets most of its energy because we breathe. All of our cells are using oxygen. And the CO2 that we're blowing out and the water that will be collected in the form of urine when you might put other waste products in there, that's efficient metabolic homeostasis. This organelle makes not only the cell, but the whole body in a state of metabolic homeostasis, where all systems are working at optimal efficiency. But with chronic disruption, smoking, lack of exercise, you can go right down the list of all of the different things that can elicit cancer. Any kind of carcinogens, microplastics, forever chemicals, glyphosate, and any of these kinds of things that would chronically damage the ability of this organelle to produce energy. Viruses, oncogenic viruses, inflammation, you have chronic inflammation. Any of those things damage the sophisticated ability of this organelle to produce sufficient energy. That's why the oncogenic paradox, which we solved.
What's the oncogenic paradox?
That was the paradox that was first put out by Albert Szent-Györgyi, a Hungarian scientist who received the Nobel Prize, I think, for vitamin C. He said he was very interested in cancer and living systems. He said there's a paradox. He said, we know multiple things in the environment can elicit cancer. We've identified these: oncogenic viruses, chronic inflammation, carcinogens, intermittent hypoxia, rare germline mutations. He said, we don't understand the common pathophysiological mechanism by which any of those provocative agents would elicit dysregulated cell growth, which is cancer. When you talk about cancer, what is cancer? It's cell division out of control. It's dysregulated cell growth. This organelle determines when cells should divide and when they should not divide. It regulates the destiny of the cell. So what happens when this organelle becomes chronically impaired? It falls back on these ancient pathways, pathways that existed before oxygen came into the environment, where all the cells were dysregulated in the growth because they didn't have this regulatory system, which is the mitochondria coming from a bacteria.
So let me play that back to you in a way, just so I make sure I understand.
I know it can be kind of deep.
Okay, so in this mitochondria here that I have in front of me, there is an ancient, because this came from the fusion of bacteria a long, long time ago.
Yeah,
that old bacteria,
about several billion years ago,
used to be very selfish and just think about itself. It used to grow on its own and didn't communicate with anybody, had its own way of growing and multiplying that was really not in cohesion with anything else. That is still in there somewhere. And although now, in its modern form, because there's been that fusion, it grows thinking about the wider organism. When it becomes damaged, it falls back on that old selfish way of growing. And that's kind of what can cause cancers. So if there's stresses on this, which could be all the carcinogenic things you described, then sometimes this falls back on that prehistoric selfish way of growing where it doesn't think about the wider organism.
It's close. In the sense of thinking, we don't know about that. Okay. We just know the consequences of what happens when it falls back on those ancient pathways. Now, here's the situation. People knew from Otto Warburg said cancer is a energy problem in the cell. Why would the cells start to ferment and produce a massive amount of fermentation waste product, which is lactic acid? Even in the presence of oxygen, 100% oxygen, they're still fermenting. That shouldn't happen. When you and I hold our breath or have a heart attack, let me tell you something. This is really remarkable. And this is another piece of information that got us on this whole thing. When people have heart attacks, they stop breathing. The heart seizes. Okay, the bloodstream immediately fills with these fermentation waste products, which are lactic acid, and the other one, which we now know, is succinic acid. Okay, wow. These two waste products. Now, if you don't start breathing in a short period of time, you're going to be dead. Mm-hmm. And you die because the neurons in your brain cannot sustain this kind of fermentation energy for very long. As soon as the heart, you give them cardiac massage and whatever, the guy's heart starts beating again. The waste products of lactic acid and succinic acid go away. They disappear because you're breathing now. You don't need to ferment when you have oxygen in the environment. And the mitochondria can utilize the oxygen in the environment. Cancer cells, to Warburg said, it's the weirdest thing. These cancer cells continue to ferment even in 100% of oxygen. Why are they doing that? And he speculated that this organelle was damaged. Irreversible damage to the organelle happened in these cancer cells. He didn't have an electron microscope at the time. He didn't have the sophisticated tools that we have today. So he projected that all on biochemistry at that time, he was a biochemist, and he said, you should not produce fermentation if you have oxygen should shut that off, and these guys should return to a normal metabolic homeostasis. And he said that's because there's something irreversibly damaged in this organelle. So a lot of people attacked him, and they said, oh, we don't have any evidence for that. Here's the beautiful thing. Some cancer cells continue to take in oxygen and make ATP. Therefore, Warburg must be wrong. We showed that. We showed the cancer cell takes in oxygen, but it's not making energy through ATP in any great amount. It's using it for ROS, these radicals that further damage and cause the DNA mutations that everybody is chasing. It's all downstream effects of damage.
So what does this mean in simple terms? Because I'm aware a lot of my viewers...
Well, it means I say, okay, so I have dysregulated cell growth. That's ultimately what the problem we're dealing with. Mm-hmm. We can't control how these cells are dividing. We're throwing all kinds of crazy stuff at them, trying to poison or radiate, surgically remove them. We're trying to do everything to stop this dysregulated cell growth. Mm-hmm. So when we look at this organelle under the electron microscope, we find these cristae are often missing. You have what they call ghost mitochondria. You got the shell, but nothing inside. Or if they're inside, they're all deformed. So we know there's a foundational principle in biology. Structure determines function. If the structure is abnormal, the function will be abnormal. This is known to all biologists except oncologists. They don't seem to understand
What's
that.
an oncologist?
Those are the people who study cancer.
So what are you then?
I'm a biologist.
You're a biologist?
Yeah. I mean, when we know that if the organelle is damaged, you're not going to be able to produce energy efficiently by oxidative phosphorylation. Okay.
I think you're a bit further down the road, Thomas, than a lot of my viewers are. For me, hearing that there's this energy engine in my cells and there's trillions of them or billions of them, and they also communicate with each other. And when this becomes stressed or hurt or damaged because of lifestyle choices that I make, energy production and efficiency will change, and that could cause this to die or malfunction in some way. That is, for me, I go, I've got it.
Okay. That's a major step forward. And then we build upon that.
Yes.
Now we build upon that. Okay. So here's the situation. We've discussed cancer cells, all of them that we have ever looked at, have defects in the number, structure, and function of that organelle. Okay. I published that big paper where I spent over a year of my time going through the early electron microscopy literature. Warburg didn't have that opportunity because that technology was not there for him. So he speculated that based on the biochemistry. But I went back and I looked at these electron micrographs of mitochondria in various cancers, and they're all damaged. There is few of them. That cristae are gone. I worked with some of the best, like Arismendi Murillo, who was a world leader in beautiful electron microscopy of cancer cells. And you can see and all the damage under his magnificently beautiful. And we have a couple of papers. But let me tell you something else, Stephen. In the cytoplasm, these organelles are also in contact with other cellular membranes, like the endoplasmic reticulum. There's a lot of what we call organelles inside a cell. You have the nucleus, you have the mitochondrion, you have lysosomes. There's intimate contacts between some of the other membranes, mitochondrial associated membranes we see. And they're also abnormal when you look at them under the electron microscope.
The ones it's talking to are abnormal.
Yeah, the ones that you can see. The mitochondria are abnormal and the membranes that contact them are abnormal.
Okay.
And that intimate contact, I'll get into the calcium signaling a little bit later, which controls the destiny of the cell. Why the cell is growing out of control? Well, first of all, it's fermenting, okay? That means it's getting energy from sources other than oxidative phosphorylation. You can take a cancer cell and treat it with cyanide or azide, or in absence of, and it's still living. It's still growing because it's not using
the oxygen pathway.
They're not using the oxygen, falling back on oxygen-independent mechanisms, which are called fermentation.
So I understand that to be that there's a malfunction in the mitochondria, which means that it no longer uses its oxygen pathway necessarily.
As sufficiently as it should. There's always some residual level.
And it finds another way to make the energy, which is how it survives.
Yes.
And then it stops communicating with the rest of the cell.
Well, it actually communicates with the nucleus to open up the floodgates to bring in the fuels that drive this fermentation energy.
It gets more and more greedy.
It has to, because you're taking an organelle that produces energy highly efficiently okay, like 34 to 36 ATPs.
With oxygen.
With oxygen. And now you're trying to replace that with fuels that give you 2 moles of energy.
So it's inefficient.
And then you get 2 out of so you're getting 4. So you have to take in order to make up the efficiency, you must have a tremendous logistic. You must have tremendous supply of the fuels that will give us energy.
Which are?
Glucose, the sugar.
Yeah.
And the amino acid glutamine. Okay. Our bodies are loaded with glutamine. That's the most abundant amino acid in our bloodstream. And evolution provided that for us. Because if we stop breathing, we use that fuel to keep the cells alive. Our gut is controlled by glutamine. Our immune system uses glutamine.
What is glutamine?
It's an amino acid. Okay.
Which we make from food.
Yeah, which we can make from food, true. Or they call essential and non-essential amino acids. Essentials are that we must eat. We must have certain foods that provide these. Glutamine is considered a non-essential amino acid. It's an essential amino acid biochemically called non-essential because we can make it from sugar. But basically, it's the most abundant amino acid in our body.
I think I get it now.
Okay, feed me back. Tell me. Let me test you.
There should be a button just down below here. And if it says subscribed, you're already subscribed. If it says subscriber, that means you're not yet. And if you're not subscribed, please could you do us a favor and hit that button. It helps the show more than you know. And according to the algorithm, you're someone that watches our show, but you haven't yet hit that button. Thank you so much. When we fall, the mitochondria falls to that prehistoric pathway where it starts making energy in a really, really inefficient way without using oxygen in the same way. Yeah. It starts relying now on glucose and glutamine to produce that energy, which is a much less efficient source of energy. So it gets a bit more greedy and it needs much more to make the same amount of ATP, which is energy. Mm-hmm. So a cancer cell can be very, very greedy. It's not responding to oxygen in the same way. And they're a bit more selfish. They start sort of multiplying without thought of the broader organism.
Yes.
So the question I have is, how does this happen? Malfunctioning of the mitochondria. What is it that I've done? You know when I ask this question as well?
Okay.
It's because children can get these cancers.
Right.
Or a 90-year-old can get the cancer. Yeah. And it doesn't appear to me that a 3-year-old has necessarily made life choices yet that could impact.
But as I said, when you consider forever chemicals that are in the environment, things that we use in our technologically advanced societies can get through the placental wall and get these into these children's organs. You have to put it together. Usually it's a constellation of things, because don't forget, I said carcinogens. Some of these carcinogens are fat soluble. Some of these carcinogens can get in and damage those during early stages of development. People always say, how do you explain brain cancer in a 6-month-old baby? Okay, what did he wasn't smoking and drinking and partying all the time, but the mitochondria in a population of cells in his brain became damaged, and that damage then led to this dysregulated cell growth, because the organelle controls when cells should divide and not divide. And then where's the energy coming from? How do you take a highly sophisticated piece of an organelle and making energy so incredibly efficient? And now we're using energy. So this organelle signals to the nucleus, called mitochondrial stress response, retrograde signaling. The nucleus acts as a respondent to what this organelle wants. So the nucleus then, oncogenes, that you've heard a lot about, they open the floodgates to bring in the glucose and glutamine that allow the cell to grow in a dysregulated way. So as you said, they go back to these ancient fermentation pathways where there was no regulation, because this organelle was not part of the problem. So what is part of the situation, the regulation?
So what are the lifestyle factors that are causing this drastically increasing the probability of this happening?
It's not necessarily what the person did in all cases. It's what the person was exposed to. That could have elicited this. That's the oncogenic paradox. So we have shown that inflammation produces these cytokines. When you have an inflammatory heat inflammation, they damage the ability of this organelle to make energy efficiently. Chronic inflammation is known to be a risk factor for cancer. Chronic inflammation. Intermittent hypoxia, carcinogens.
What's intermittent hypoxia?
It's like the sleep apnea, that kind of thing.
Oh, okay.
Warburg had clearly shown that intermittent hypoxia on cells would damage the efficiency of oxidative phosphorylation, leading to a compensatory fermentation. So you have to compensate, because let me tell you, if you don't compensate, you're dead. The cell dies.
When we look at the populations around the world that have the most prevalence of cancer, it doesn't appear to be some of the countries like Niger, Gambia, Nepal consistently rank at the very bottom for cancer incidence. Conversely, high-income countries like Australia, New Zealand, and the United States have the highest rates of cancer. Why is that?
It's because of our technology. We are still Paleolithic man, and our biology has allowed us to store energy efficiently because of times of famine. We are now in a new environment where we have massive amounts of highly processed carbohydrates, inactivity, emotional stress. We have poor sleep habits. You pile all those together with the exposure to carcinogens and whatever, and you chronically damage this organelle. And in some organs, you can get breast cancer, if it's a lung, if it's whatever it is, that organelle becomes chronically damaged in some populations of cells in a particular organ, and you can elicit dysregulated cell growth as the result of that. You know, what I find is in the paper that we have with the chart, if you can keep your mitochondria healthy, because don't forget, Paleolithic man, our ancestors from 500,000 years ago, or modern men, like you said, in these countries, living according to traditional ways with minimal interference from modern diet and lifestyle issues, have lower amount of cancer in general. And this is what Albert Schweitzer found, the famous humanitarian physician. He was specifically looking for cancer in African tribes. And he said, remarkably, it's extremely low. What are these guys doing where Western society has a lot of cancer and these Africans have living according to the traditional ways? So they have a lot of exercise. They're eating all organic foods. They're not under the same kind of stress or exposure to chemicals that modern societies have. And you find out you have very low cancer. Like, for example, dogs are all evolved from the wolf. Wolves in the wild rarely have cancer. The domestic dog, cancer is the number one killer of the domestic dog. What is the dog doing that the wolf? The wolf is out running around eating natural foods. The dog is in an apartment somewhere, gets a dog walker once a day, right? And the next thing, the dog is obese and full of cancer. So it all comes down to what you do to maintain the health and vitality of the mitochondria that reduce the risk, and that's what this chart I'll show you has, reduce the risk of damaging this chronically. Okay, so that can explain in large part why modern societies are struggling with chronic diseases, not only cancer. We have type 2 diabetes, we have obesity, we have high blood pressure, we have a whole, even neuropsychiatric problems. If you can protect and keep this organelle healthy, you reduce risk. Now, people say, well, cancer has to be genetic because we have inherited genes that put us at higher risk, like the BRCA1 for breast cancer and the LIFRA-MNE for a variety of other cancers. Our paper in this pile, done by Bob Kaplan, he went through and looked at all the genetic risk factors.
Which paper is it?
It's one of the ones published in Oncology. But none of these mutations are 100% penetrant, meaning that they're secondary risk factors. A primary risk factor would be every time that mutation is there, 100% of the people, because I work in Tay-Sachs disease, I work in inborn errors of metabolism. Those mutations are 100% responsible for that condition. If there's no gene mutation that's 100% penetrant, you have that gene, you're going to 100% get cancer. Most of them are what they call incompletely penetrant.
So what does that tell us about the nature of?
Well, and then we went back. What Bob did is he went back and he looked at what every one of those gene mutations in some way disturbs the efficiency of oxidative phosphorylation in that organelle.
In the mitochondria.
In the mitochondria. We looked at, we have all the evidence, all the risk factor, all the genetic, just the front page there. I was going to show you the hard data, but you got it. So anyway, all of them damage the efficiency of energy through this organelle. So that's like carcinogens. That's like viral infections. The viruses that hepatoma and papilloma, their products will go in here and damage it, or they will replicate inside this organelle, screwing up the efficiency, causing a compensatory fermentation, causing the dysregulated cell growth through abnormal calcium signaling, causing cells to no longer be responsive to their neighbors. Is that clear? If I can make you understand this, we can make everybody understand this.
Yeah. So the reason I spend a lot of time asking why and asking for clarification is because when I do this show, I then go out into the real world and I meet the people that listen.
Yeah.
And one of the groups of people that listens are young offenders. And when I went and visited them, I pointed at the episodes that I thought would help them.
Yeah.
And one of the young offenders said to me, I can't listen to that episode because the words you used were too big. And I remember thinking to myself.
Okay, and I get that all the time, but guess what? Now we have AI. And you can take this statements and put it into AI right on it'll dumb it down for you. Mm-hmm. So that's a tool that we previously did not have. Mm-hmm. So I use that all the time. I said, when you hear me speak like this, don't think I'm arrogant. Don't think I'm just, these are the terms that we use when you're part of the academy.
Yeah.
Okay. But we can take those terms now, and AI can do a wonderful job in synthesizing. Oh yeah, I know what he's talking about now. But without that tool, then it becomes like you said, well, I can't understand anything. Mm-hmm.
I've got 60 seconds and I'm going to show you how much I can get done because of our sponsor called Whisper Flow. And for those of you that don't know what it is, it's a business I invested in that turns your speech into text in any app or device. I'm going to post into our Slack channel, which rewards whichever team member conducted the most experiments this week. Hi everyone, here is this week's experimenter of the week. Congratulations to the Diary of a CEO trailer team, which is Ant, Liv, Dom, and Cam. You guys have won. Okay, now I'm going to open Gmail. So here is one of our founders on an email chain that I want to connect my team with. All I have to say is add my team's emails and Whisper will do exactly that. Now a quick message to Juan, who does my schedule every single week. Hey Juan, could I record on Wednesday at 2 p.m? Actually, no, do you know what? Let's record at 3 p.m. on Wednesday. Whisper Flow is 4 times faster than typing and it is incredibly easy to use. So if you want to give it a go, all you have to do is head to whisperflow.ai/Stephen to download it today. If you know me, and if you've listened to this podcast before, you'll know how obsessed I am with sleep. I've been on a bit of a journey with sleep. I see it as the single most important thing that I have the privilege of having control over. And that's exactly what our sponsor 8 Sleep are. It's a very, very intelligent piece of material to sleep on. Here's what the 8 Sleep pod does. It monitors your body while you're sleeping. And with their AI, it adjusts the temperature for you using billions and billions and billions of hours of sleep data. And members have reported up to a 34% deeper sleep and falling asleep up to 44% faster. Me and my fiance, Melanie, sleep on different parts of the bed and it adjusts my part of the bed to my body and her part of the bed to her body. So if you want to learn more about this pod, go to 8sleep.com/Stephen. Big opportunity. I'm not kidding. Give it a try. I really want to just make sure I tick off the box of cause factors. So you mentioned stress. Mm. You mentioned sleep. Mm. I currently don't have cancer, as far as I'm aware, God forbid. But I want to do everything I can to prevent the probability. Yeah. And from what I've understood, that means protecting my mitochondrial function.
Yes.
By living a lifestyle where I'm not creating this sort of like crazy oxidative stress on the mitochondria. Right. So give me a prescription of how I should live my life to keep my mitochondria healthy.
Well, that's why we developed the Glucose Ketone Index calculator, the first biomarker tool that can allow people to know the level of health of their mitochondria. Because when you shift from carbohydrate fuel to lipid fuel.
What's lipid fuel?
Fat.
So ketos.
Ketones are a water-soluble breakdown product of fatty acids. Mm-hmm. Okay. So we store adipose tissue. We store fat.
Which is the belly fat.
All over. We have fat on our arm.
On the outside.
Yeah. So on the outside. That was there because as a species, we had to survive in the most harsh environments. And we were food was not always there. So we had to survive all kinds of famine, all kinds of absence of food. Our bodies are so, it's a machine that was honed over millions of years to be super efficient. So glucose is gold, sugar. Okay. You either burn it or you can store it as fat. Okay. That's the key. But when you're not bringing in sugar, that stored fat now moves into the bloodstream, goes to the liver. It's like taking a branch and putting it in a chopper, and out come these little soluble ketone bodies. They're breakdown products of long-chain fatty acids. They can replace sugar for the brain, for the muscles, for most other cells in the body, except erythrocytes. But they can replace the energy of glucose, okay? So, and that's how we evolved. But we're now in an environment where we have massive amounts of highly processed carbohydrates. And we don't want to pee them out unless you have diabetes or something. So we store them as fat. So we have an obesity epidemic as the result of our evolutionary ability to store energy, which kept us alive as a species. Because if we weren't able to store the fat in 500,000, we would have all been extinct. You and I, this conversation would never exist. We would never have existed as a species, except for our ability to store energy. And we burn energy efficiently in these organelles. So this is all a very highly efficient machine. So when we lose that ability, when we have so much energy in the environment, stress, no exercise, all this, we store more and more fat. We produce an environment that's very damaging to this organelle.
Wait, say that again. So how does stress impact that?
Stress elevates corticosteroids. When you're under stress, you get into a fight, you get into an argument, or you're stressed out by business deal going bad or whatever. Corticosteroids elevate blood sugar, contributing to systemic inflammation. It's okay for a short period of time to be pissed off at something, but it's the chronic stress, the chronic, like looking at the cell phone, doom scrolling, all this kind of crazy stuff while you're eating a big Twinkie, doom scrolling, eating Twinkies, not moving. All of this creates stress on this organelle in some population of cells.
It makes it work harder.
It's damaging because you produce reactive species that damage the efficiency of this organelle to produce energy effectively. And that either will kill the cell gradually if it can't use compensatory fermentation, or predispose you to cancer. So either way, it's unhealthy. So we have chronic disease. Cancer is the number one big dog in the chronic disease world. I mean, it's the one that people fear the most. Type 2 diabetes, cardiovascular disease, dementia. All of these are part of damage to this organelle in one way or another. Like I said, for Parkinson's disease, when that organelle gets damaged, the cells of the substantia nigra die. They are incapable of compensating with fermentation, so they up and die. Cancer is very rare in neurons of the brain. The glial cells of the brain form these brain tumors mostly, but neurons can't compensate with fermentation, so they die. So you either get compensatory ancient fermentation leading to dysregulated cell growth, which we call cancer, or we get cell death leading to chronic diseases.
What about sleep then? What's going on with sleep that's causing?
Sleep is a way we can restore the energy efficiency of the mitochondria.
If we're well slept.
If we have good sleep, yeah. Everybody feels good when you have a good night's sleep. Your body feels rejuvenated because you're not stressing out. You're reducing the ability of this organelle to manage the metabolic environment. If you're up all night and you're like stressed out, and you're never given this organelle in a particular cell in a particular part of the organ of the body, you get neuropsychiatric problems, you can get digestive problems, you can get cancer, you can get type 2 diabetes. You have a whole, and we put it in the paper there, all the different stress, all the different things that can chronically or acutely damage oxidative phosphorylation.
So sleep basically gives the mitochondria a little bit of a break.
Yes. It gives your whole body a break, let's be honest. But you pile those things on together. Lack of exercise. Our ancestors, what do you think, our ancestors? You know how hard it is to run down and kill a big buffalo or a woolly mammoth? I mean, you're exhausted after doing something. As a matter of fact, you chase these animals, you separate, and this is another thing that was really interesting, came out of Israel, I think it was last year. They looked at the cavemen, what they were eating. They were eating the strongest members of the herd. Leading to the indirect extinction of these animals. They found out that if you can eat the strongest member of the herd, you'll get the vitality of that or buffalo or elephant or whatever the hell they were eating, because they knew the marrow and the physiology of that organism at that point in its life could provide you with the strength that had. Now, when you eat the strongest members of the herd because you want to be tough, you're putting the old and the young vulnerable to predators, leading to the extinction And this is what a big paper came out of Israel. They looked at these cavemen, what they were eating like 500,000 years ago or whatever they're doing. So humans indirectly caused extinction of other species, in part, because they were eating the toughest guys in the herd. So because they felt that if I eat those guys, I'm going to be strong too. And in a way, they're right. But all of it has to do with the energy efficiency of your muscles, your brain, your ability to be resilient, endurance. I'm telling you, these guys were chiseled. They weren't dying from type 2 diabetes, cancer, right, dementia. They were dying from infections and injuries, and child mortality. Were mostly killing our Paleolithic ancestors. But when you bring your body back into a low glucose ketone, you're actually going back like you were. And this is why we developed the Glucose Ketone Index.
What is in that envelope in front of you?
Well, this is it's a paper that's under embargo because they think it's going to be, the world thinks it's going to be very important. And it is. So, and what it is, this is a way to keep that organelle healthy. So this is a way to manage energy efficiency in the body.
And this hasn't been released yet?
It hasn't been released. Okay, it's coming out. It's going to be a lead article in the Frontiers in Science. And not only that, the paper was written for the scientists, and then the journal decided to make a second copy for, they call young minds. So letting kids that are like 8 to 12 or 14 years old synthesize it down. And one of my colleagues said, that's probably what most people will be reading because they don't want to know about the bioenergetics that actually goes on inside this organelle to explain why this chart means something.
And you've been working on this for some time?
Well, I built the GKI. So let me tell you the story. There was a woman, an American woman, a lawyer, Trudy DuPont, who developed a kind of a brainstem tumor. And after I wrote my book, that book there, that's my only book. Anyway, Trudy wanted to use this metabolic therapy. She stayed alive much longer, over 10 years with this. She eventually passed away, unfortunately. But so I was measuring, because we knew that the tumor cells needed sugar to grow. Otto Warburg showed that, and many other people showed that. And they can't burn ketones because you need a very efficient mitochondria to burn ketones for energy. Our normal cells can burn ketones for energy, and that gives us tremendous, we can actually breathe lower oxygen, more energy if you can burn ketones efficiently in this organelle. But if the organelle is damaged, they can't use the ketones. They can't burn fatty acids or ketones, which stores lipid drops. It's one of these big papers here. Stephen, you can't believe how people misinterpret information. They see droplets of fatty acids in the cytoplasm and say, you see, the cancer cell needs all that fatty acid. No, they can't. It's there to protect them. If they try to burn it, they blow this up and die. So there is a storage of fat. They can't burn fatty acids or ketone bodies. So I knew cancer needed glucose, and I knew cancer couldn't burn fatty acids or ketones because this organelle is broken. So I'm measuring glucose and ketones independently in Trudy. She's doing the finger prick thing, sending me the information back and saying, oh, here's my glucose, here's my ketones.
Okay, so I have a ketone glucose reader in front of me.
Right.
If I put my blood on this strip, it tells me my glucose levels. If I put my blood on this strip, it tells me my ketone levels.
Right. But if you look at them independently, glucose is very volatile, very variable. And this is why I developed the glucose ketone ratio. Because Trudy had a parking spot that was for handicapped because she had a cane. Her brainstem glioma was preventing her from walking as effectively as normal people. So somebody took her parking spot. She was bullshit. So she ran upstairs and took her blood sugar, and it was 186 milligram per deciliter. It was very, very high. So, and I know she was on a ketonic diet. And she emails me and says, I'm going to die. My cancer is going to grow fast. I say, what's going on? She said, my blood sugar is like 186. And, it's supposed to be, you told me it was supposed to be 60 or, 50, 65 or in that zone. She says, so I said, what's your ketone level? Oh, it's still, like you just had 0.4 millimolar, or I think it was 0.9 millimolar. I said, well, that didn't change, right? No, just the sugar changed. So I said to the students that were working, Josh Weidenbauer, I said, Josh, this trying to measure these two independently is a bullshit. You can't. This is hard to figure out. So what we decided to do in millimolar, because glucose comes out in milligram per deciliter, whereas ketones come out in millimolar. So we had to convert glucose to millimolar and divide it by the ketone in millimolar, and then you get a number that's not all over the world. It's very stable. So we were able to, because of Trudy, that one cancer patient, we developed the ratio of this. Then later on, we realized that this ratio is a statement of how healthy your mitochondria actually are. So when you have these low ratio, you're a Paleolithic man. You're back in the zone where we didn't have chronic diseases because we didn't have damage to the organelle that would cause those diseases. So Paleolithic man, think, where are they getting their pastries? Where are they getting their cakes and sweets and all this other kind? They didn't have it. They weren't there because of choice. They were there because of circumstance. So and we learned Paleolithic man was always in some sort of a state of some ketosis because they wouldn't have food for periods. They were very active in their exercise. They didn't have chronic diseases, but they had other kinds of diseases. So then my student Derek Lee, myself, and Christos Chernopoulos, we started to make a ratio chart. Now, these are the numbers that you get when you divide your sugar by your ketones.
Okay, so my sugar by my ketones. So if I did my glucose measure now on this little reader
okay,
here.
let's see what your GKI is.
Oh, you want me to do it? Okay.
Okay, what you had a glucose, you had a ketone with 0.4 millimolar.
Yeah.
Okay, what was your sugar? So we can do the division right now and tell you what you have.
You can get these little ketone.
Oh yeah, it's a Keto Mojo. And you can also get them now for wow, this guy's skilled at doing this.
I travel with one of these, believe it or not.
Yeah.
So I have one all the time.
Wow.
90.
90? Okay, so you have to divide. You're not getting doesn't this give you the push button and give you the GKI right away? Because the new ones have it. So you have to divide 90 by 18 and you get a number.
5.
5. So divide 5 by 0.4.
12.5.
Okay, so here you are. 12.5. You're down here in the prevention zone.
Nice.
Okay, so this is where Paleolithic man mostly lived. Paleolithic man lived in the yellow-green zones because they didn't have access to all of the things that would drive up your blood sugar and keep your ketones. When your blood sugar goes through the roof, your ketones are really low because insulin is now driving it up. So that's good. 12, huh? Mm. So I did the carnivore diet for a week, eating big ribeyes. You like ribeye steak?
Yes, of course.
Okay, ribeyes, bacon and eggs, lamb. So I did it for a week, and I was able to get down to 10. Okay, and I could get lower, but I was loving the ribeye so much I ate a little too much of it. Right? You have to have some level of discipline. Yeah. But people, this is what we call the zone of prevention. It's very hard to get cancer or chronic diseases when you're in these zones because you're keeping this organelle quite healthy.
When you live in these zones consistently?
You don't have to live consistently because humans, we evolved as a scavenger species. Yeah. We would engorge ourselves because we knew it wasn't happening every day. Modern man is living in the feast every single day. Yeah. And that's why we have all the chronic diseases. This is the red zone, is the zone of risk for chronic diseases and cancer. And when you look at the obesity epidemic, you look at all these things, these guys are and it's like we can visit the red zone. We don't want to live in the red zone.
So if I was to visit the red zone, it would look like me eating high carbohydrate diets, lots of sugar.
Yeah. No exercise.
No exercise.
Yeah. And basically modern man.
And also eating 5 meals a day, like snacking all the time.
Yeah. Oh, then you'd be, we have, there's document cases, we have them up to 500. You can get,
You're joking.
Oh, yeah. GKIs of 500. You have people with, blood sugars about 400 or 500 milligram per deciliter. I mean, you could do and 0 ketones. I mean, you do the math. It's unbelievable.
You're basically saying I want to keep my blood glucose levels,
and you want to have some level of ketones and
my ketone levels somewhat as high as I can.
Well, you don't want to go because people then hear the physicians listening and they go, "Oh, he's going to go into ketoacidosis." Hey, people, give me a break. Ketoacidosis is like when you have ketone levels levels of 15 to 20 millimolar. Are you kidding me? What is yours, 0.4? That's called nutritional ketosis. That's how we evolved. When you have type 1 diabetes, where you can't control sugar or insulin, you have no insulin responsive, you're going to get high levels of sugar and ketones. This is a pathological condition. Most of type 2 diabetes, these are all pathologies based on damaging oxidative phosphorylation. So what this chart does is, for the first time, and we put it together because we did all in the paper discusses the bioenergetics, what we're finding in cancer is that if you can get into the green zones where your blood sugar is low and your ketones are elevated, you hammer the hell out of these tumor cells because you're taking away one of their two primary fuels driving dysregulated cell growth. Okay, and as the ketones go up, the rest of your cells in the body are getting super healthy. The tumor cells can't tap into the value of a ketone because the organelle needed in the tumor cell to do that is corrupted structurally and functionally. Am I clear about that?
Yes.
Okay. So ketones will make you healthy, the normal cells of your body, but cannot be used to help the cancer cell because you need a good structural functional organelle to burn them. So they become marginalized. And if the ketones go up, they're actually toxic to that cell to some extent. So, but they're still alive. The cancer cells are now incapacitated. We showed you get rid of the abnormal inflammation, you get rid of the angiogenesis, the abnormal blood vessels. You're taking an angry tumor and making it much less angry, much less inflamed, more indolent kind of a tumor, but it's still there. It's not, because the other fuel that's keeping this cancer cell going is the glutamine. Okay? So now, when you have the patient in this green zone, this is for management now, Stephen. This is prevention is never having to deal with what I'm talking about. If you're living in the yellow zone, the probability of getting cancer or chronic diseases is already reduced. Okay? But now you have some poor guy out there, he's living in the red zone his whole life. He wants to manage the cancer that he has. He has to get down in the green zone and try to stay there as long as he can. But the cancer will still grow because it has access to glutamine. Okay, and glutamine is always, here's the bloodstream. Look at, you have this much blood. Cancer needs that, so you always have a surfeit of glutamine. So you have to come in now with drugs. And the drugs, like repurposed drugs, to target the glutaminolysis. With this one here, this BMC big paper here, okay, this paper and the new one we have with the ketogenic for the childhood high-grade glioma for kids. So once you get down here, you come in with drugs that target glutamine. I've looked at one, and that's embendazole. Okay, how did I come to that realization? People knew that embendazole had some therapeutic benefit about cancer, but they don't believe it until you show the mechanism. That paper shows the mechanism. It targets glucose and glutamine. Now this one targets glucose and glutamine, the two fuels driving the dysregulated growth of the tumor. Okay, so here's the mitochondria. So it's getting the glucose in the cytoplasm from the sugar and it's fermenting that. And then also the amino acid glutamine comes in. You have to block the glycolysis and the glucose, these two pathways. You have to restrict availability of glucose and glutamine together at the same time.
Yeah.
I speak only about things that I have tested in my lab and published papers on, like this. So you have to the cancer field doesn't understand that the cancer can't grow without glucose and glutamine and can't switch to fatty acids or ketone bodies.
That's still not going to kill the cancer, though, is it? It's just going to...
Yeah, we don't ever use the term cure because some of these tumors... Now, let me tell you, we have people like Pablo Kelly from Devon, England. He had the glioblastoma. He didn't take any radiation or chemo. He just did metabolic therapy. He lived for 10 years. He was diagnosed with an inoperable glioblastoma. They wanted to irradiate and poison him with the drugs. He said no. He was one of these naturalistic kind of guys. And he lived for 10 years. And the tumor became operable. He had 4 debulking surgeries on an originally described inoperable cancer, cut out 4 times, because once we put the metabolic therapy, the demarcation of the tumor, whoa, a neurosurgeon says, I think I can get this out. But he never got rid. He lived with it for 10 years, had a couple of kids. He died from a cerebral hemorrhage on the last debulking surgery. He never died from the tumor.
But you're saying that the two work together in tandem.
Yes.
You're saying that the chemotherapy works in...
Now, that's another thing. So what we do, now this is very interesting. So if you put the patient in nutritional ketosis, the ketogenic state of nutritional ketosis facilitates the delivery of drugs to the tumor cell. It actually you can use lower doses of drugs and you get bigger effect. The therapeutic benefit increases with lower dosing.
So you want to be in ketosis when you do these chemotherapy, radiation therapy?
Yeah, and then you use much lower doses. This is what we're doing in Istanbul clinic. We're taking pancreatic cancers. These guys live in 4 and 5 years. What are we doing? And advanced breast cancer and all these terminal cancers. We put them into some level of ketosis, and then you come in with the standard drugs, cisplatin, carboplatin, whatever you want to do, but you cut the dosages down big time. And then they have tremendous, and you put this is what the title of the paper is: Ketogenic Diet as a Metabolic Vehicle for enhancing therapeutic efficacy.
The current body of research suggests that being in a state of ketosis can act as a helper therapy, enhancing the cancer-killing effects of chemotherapy while simultaneously protecting healthy cells.
Yeah, right.
Progressive oncologists are currently using ketogenic diets alongside standard chemo to maximize its efficacy.
That's right. That's what we're doing in Istanbul. And also in Greece, we're doing those same things. So you can use this.
When you enter a fasted or ketogenic state, your healthy cells essentially go into bunker mode. They slow their division, conserve energy, and build up their defenses. Cancer cells, however, do not have this evolutionary off switch. They continue trying to rapidly divide. When the toxic chemotherapy hits, your shielded healthy cells survive it much better, while the exposed rapidly dividing cancer cells take the full hit.
Yeah.
Okay.
Yeah.
Interesting.
Yeah. In other words, you make with the tools you have work better. The problem in the field of cancer today is they're not using the tools in the correct way. Now, let me give you another example. If you take immunotherapies, you hear about these things, chimeric antigen T receptor, PD-1, PD-L1 inhibitors. They're called precision medicines, right? So look, they're designed to attack a molecule on the surface or stop that cell from being resistant.
Mm-hmm.
If you would try to attack, and what they do oftentimes, they come after you've failed chemo and radiation, they then come at you with an immunotherapy. The metabolic pressure shrinks down your tumor, makes it very indolent, non-aggressive, and the rest of your body is healthy. You're not going bald, you're not bleeding gums, your microbiome isn't blown to hell. So, and then you can come in with low-dose chemo, immunotherapy, because what's ever left in that remaining residual mass, they may all have something in common for having survived all this, right? So now you can come in with a precision medicine and possibly resolution.
I thought this was fascinating. It says chemotherapy creates massive oxidative stress, i.e. damage inside the tumor. To repair the damage and survive, the cancer cell requires massive amounts of glucose. So if the patient is in ketosis, the tumor's glucose supply is essentially cut off. The cancer cell can't repair the DNA damage caused by your chemo, leading to faster tumor death. Yeah, interesting.
Well, don't forget, also, listen to this. And as another thing, people go in. What protects the tumor cell from chemo and radiation is the waste products of fermentation. The lactic acid and the succinic acid that are dumped out of this raging beast prevent these other therapies from working. So if you want your therapy to work, you got to target those two fuels together at the same time. And when you do that, now this cell, the shield is off. These things are super vulnerable to even low doses of chemo and radiation. And the immunotherapies, look at, if you have an immunotherapy, you try to attack the beast when it's at its strongest, you're not going to win. And this is what happens. You get only partial response. In the field of cancer today, they think living an extra 6 months is a major breakthrough. We're talking about living an extra 5 and 6 years. This is what's really important.
I just, I was doing some research to figure out if oncologists, so cancer doctors, are currently recommending the ketogenic diet. And it says the vast majority of mainstream oncologists do not recommend the ketogenic diet to their newly diagnosed patients. In fact, if a patient brings it up, many doctors will actively advise against it. And the reasons for that, number one, is the fear of cachexia.
Cachexia, yeah.
Cachexia. Cancer cachexia is a severe wasting syndrome where patients rapidly lose muscle and fat. It is a massive problem and a leading cause of mortality in cancer patients. Because the ketogenic diet suppresses appetite and often leads to weight loss, oncologists are terrified that a strict keto diet will accelerate cachexia and weaken the patient.
Well, that's because they have not heard what I just said with respect to the biology and biochemistry. Okay. Cachexia, there's two ways you can lose in cancer patients. Cachexia is the ability of the tumor cell to mobilize energy out of the muscles. It's taking the glutamine out of your muscles and feeding. This is one of the two fuels that's driving the beast, is glutamine. Where are they getting the glutamine from? They're getting the glutamine not only from the bloodstream, but they dissolve your muscles as part of that process. So when you put a patient in nutritional ketosis, the weight loss is therapeutic weight loss. Cachexia is pathological weight loss. Now, the other way you can lose weight is you take a high dose of chemotherapy.
I travel all the time. I made a rule in my life that I'll only travel with a cabin bag. The problem with this is there's not much space, and here's the solution. It is called an Extra 1% travel pack, and I teamed up with Extra to make this. Typically, I can only bring some of my black shirts, and it's a trade-off of which black shirt shall I bring. How many of these do you think I can get in here? So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's try 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so that's 24 black t-shirts. Here's where the magic comes in. Zip it up, make sure it's nice and sealed, and then use this little contraption. Stick it on there. I can now take more than 20 black shirts with me, which will last me 3 weeks. So if you travel frequently and you want to get one of these so you can save more space and be away for longer, go to extra.com and use code DOAC for 10% off our collection.
And I think some of the background context here is that mainstream oncology operates on the sort of somatic mutation therapy, which is the belief that cancer is fundamentally a genetic disease driven by DNA mutations. And because their training focuses on genetics, their treatments are designed to target DNA and cell division, like chemoradiation targeted genetic therapies, rather than manipulating cellular metabolism. And lastly, as mentioned, I think we talked about this earlier, mainstream medicine requires massive, multi-center, double-blind phase 3 clinical trials before a protocol becomes the standard of care. So dietary interventions rarely get the level of funding. So oncologists lack the institutional green light to prescribe them to patients, and they tend to say to them, eat what you can.
I don't blame them. They're good. Many of them are good people. The problem is the system doesn't train them to understand the biology and biochemistry of the disease they're treating. Some of them become very resistant to this. They get angry because why wasn't I told this? Well, first of all, they're not reading these papers. You ask them about it. I never read it. Well, how are you going to know anything if you don't read the literature? Listen to this. The National Cancer Institute, the NCI, on their website says cancer is a genetic disease caused by what you just said. Okay. I said, why don't they put the articles in there showing all the tumors? They can't find any mutations. The somatic mutation theory says that cancer is caused by random genetic mutations. So now, new sequencing of normal people like you and me are finding mutations in all these driver genes in cells in our body that aren't in dysregulated cell growth. So we're calling them wild-type cancers. What do you mean a wild-type cancer?
You lost me.
Okay, the nucleus of a tumor cell, a raging tumor cell, what's causing that cell to grow? Is it the mitochondria in the cytoplasm, or is it the mutations in the nucleus? Okay. So according to the somatic mutation theory, it's the mutations in the nucleus that are causing the dysregulated cell growth. You take that nucleus and put it into an enucleated normal cell.
Yeah, and there's no cancer.
There's no dysregulation.
So it must be something else.
Then you take the nucleus of the normal cell and put it into the cytoplasm of a tumor cell, and you get dysregulated cell growth.
So it must be something other than the nucleus.
Yes, the mitochondria.
Interestingly, it says...
So mitochondria are controlling our destiny. And the field of cancer has yet to understand it, accept it, and then say, well, we can't do any of this until we double-line crossover. That's just, what do you mean? The science is telling us this. That's your way of protecting a broken system.
Are you pissed off about this? Because you do seem pissed off about this.
Well, who wouldn't be? Stephen, there's 1,700 100 people a day in this country dying from cancer. I don't know the English. Listen, that comes out to 70 an hour. And it gets worse every single year. And the last time I was on this show, you guys used some old data. Look it up today. It's 2026. American Cancer Society says this year in 2026, we will have 626,000 souls leave the planet from cancer. Okay? This 2026. And every year it gets worse. So when you hear all the breakthroughs, we have television ads in Boston for the cancer center. Breakthrough after breakthrough after breakthrough. All these different, they come on. And all we do is get more dead cancer patients. Raise money for cancer. Where's the accountability for all the money you're raising? When is the people going to wake up? You don't make someone healthy by irradiating and poisoning them. You've got to understand the biology and the biochemistry of the disease. I have the concepts and the proofs. But the physician who works with the patient on a clinic basis, they're the ones that must apply this to the clinic. So there's two different things here. There's the hard science that's the bedrock for this, and then there's the clinical person who has the practice. So that practice does that. Together, you get great success, or better. I say success better than anything that's out there today.
The American Cancer Society recently released its latest projections for 25 and 26, and the data paints a fascinating dual-sided picture. More people are getting diagnosed with cancer. New cases, the ACS projects over 2.11 million new cancer diagnoses in 2026. This translates roughly to 5,800 new cases every single day. Approximately 626,000 Americans are expected to die from cancer in 2026.
Right.
About 1,700 deaths per day. Lung cancer remains the leading cause of cancer death, projected to cause more fatalities than colorectal and pancreatic cancers combined. I also just wanted to pick up on a point we were talking about earlier, which is about the metabolic approach to cancers. It says here, and this is going to the point about, people telling you to just eat whatever you want while you're, managing cancer. Because the primary goal of the hospital dietitian is to prevent weight loss during brutal chemotherapy regimes, patients are frequently told to eat whatever they can and eat whatever they can keep down. It is incredibly common for cancer patients to be handed meal replacement shakes, which are often packed with corn syrups and refined sugars, ice cream, and high carbohydrate comfort foods, just to keep their calorific intake up. From a metabolic perspective, this is a tragedy. While it keeps weight on the patient, it simultaneously floods the bloodstream with glucose and insulin, directly feeding the tumor. And while keto is not the standard of care, the landscape is beginning to slowly shift. There is a growing minority of integrative oncologists and specialized metabolic clinicians worldwide that actively prescribe therapeutic ketosis alongside conventional treatments. Those doctors use the keto diet and fasting protocols to protect healthy cells and sanitize tumors before administering lower, more targeted doses of chemo.
Yeah, that's what we developed. That's our plan. That's what we're doing. Okay, we do that because we understand the biology and biochemistry, and that's why we're developing the new society called MORE, the MORE Alliance, Metabolic Oncology, Research and Education. This is bringing together what you just mentioned there in a logical approach to manage cancer. This is a logical approach based on the hard science of decades of research, initiated originally by Otto Warburg and then continued by our group at Boston College.
The American Cancer Society says that breast cancer is increasing, prostate cancer is increasing, pancreatic cancer, melanoma, HPV-associated oral cancers are steadily increasing in the incidence of severe cancers.
Yeah. There has been no major advance in managing glioblastoma in 100 years.
What's glioblastoma?
That's the deadly brain cancer. Okay. That killed Teddy Kennedy from Massachusetts, Senator Kennedy, John McCain, President Biden's son, Beau Biden. It's killed a lot of various people, and it's considered a death sentence. So no. We're keeping these guys alive. Okay, we're not saying we cure the cancer, but we can certainly keep them alive a lot longer. Pancreatic cancer, always considered so bad. We're getting very excellent results in managing pancreatic cancer using metabolic therapies. We know what to do, and we know how to do it. I have clinicians that work with me, dietitians that know how to manage cancer effectively. We can do it right now, today. if someone were to say, Seyfried, get your group together, let me see what you can do. I will put up our metabolic therapy against any trial from any of these pharmaceutical companies. We can keep these people alive a hell of a lot longer to participate in our society. We're not doing that.
If you were made president today, Thomas,
Of the United States?
Of the United States.
Don't go there.
I'm going to go there.
Those guys are not, let's put it this way, they're not scientifically literate.
But you're
I would have to be, yeah, right.
You're Professor Thomas Seyfried, you're now president of the United States, and your primary objective is to bring down this 1,700 Americans that are going to get cancer a day. Is it get cancer or die from cancer?
No, they die from cancer.
Okay.
1,700 a day dying from cancer in the United States. 70 an hour. Think about it.
You can put in place policies to stop this happening and to also help people manage it better. What is it you do?
First of all, we wouldn't throw out everything. Just like I said, we have a strategy now to manage cancer effectively.
Okay, so you also want to prevent it.
We're not going to get rid of the drugs that are making billions and billions of dollars. We're just going to use them at lower dosages in a different
But you also want to prevent it in the first place.
Well, preventing it, that comes back to our chart.
I'm going to write down the manifesto. So what do we do to prevent these 71 people an hour dying of cancer?
Well, that has to come from government policies.
Okay, you just got promotion. You're now the king of the United States, so you don't even need to ask anybody. What do you do to prevent the 71 people a day dying of cancer?
It's going to be education.
Education number one.
Education number one.
Okay.
You have to let people know that those, and now let me tell you another thing that's really important. It should not be any government or government official telling anyone what they should or should not eat. Okay? The power of this chart is personal. You're emboldening the patient. They have to know. We're not going to tell somebody, oh, if you continue to eat bad food, you're at high risk. And that person, I don't care. I'll smoke cigarettes and the government's not going to come into this guy's house and take away the bad food. No. That should never happen. Those foods are there because they give us pleasure. But they should be, the knowledgeable person would be to say, I like to have it every now and then, but I can't live in that environment. And the other thing we do terribly in this country, the poor people in these food deserts where you only get crap food. And there's a tragedy in itself. To go to Whole Foods where they have the expensive ribeyes and all this stuff, that's much more expensive. A lot of people can't afford the kinds of foods that will put them in these better healthy zones.
So we're going to make healthy food more cost effective, cheaper.
Those are easy words to say, but in practicality, it's not.
And what kinds of foods should people be eating?
Well, I think they should just try to avoid the highly processed carbs. Okay, you don't listen to this. And exercise. There's a lot of things we can do that would mitigate the inflammatory conditions put on this chart. The goal here is we know what keeps us healthy. It's the efficiency of that organelle. We want to do everything possible to keep that organelle healthy. We will reduce dementia. We will reduce diabetes. We will reduce obesity. And they say, well, GLP, I don't want to do. And human beings are the kind that I want a quick fix for everything, right?
Ozempic. How about some Ozempic?
What is this, GLP?
Yeah, GLP-1.
Okay, we don't, first of all, we haven't done any research yet to know where a GLP would put you on the chart. We do know one thing, it lowers blood sugar. How high of a level would it bring to ketone? Because it's the ketones that keep the organelle healthy. So I'm lowering blood sugar, but am I raising the ketones that enhance the bioenergetic efficiency of the organelle? I don't know what number, and it hasn't been done yet. I haven't seen any papers coming out.
Okay, so we'll keep the Ozempic off the table, but you're saying exercise number 3. So I've got education, kill the food deserts so people can get healthy food.
Yeah.
Stay away from the ultra-processed stuff. Number 3, exercise. We're going to give everybody free gym memberships and whatever else they need.
Yeah. Reduce stress, emotional stress. You got to do that. And there's a lot of ways. Music therapy. There's a lot of different ways you can
meditation,
reduce it. Friends, happiness. All of those reduce stress. So I had a guy from Korea. I think it was Japan or Korea. We did a big meeting one time, and he didn't tell me what to do. He says, you want to get cancer, if your goal in life is to get cancer, you got to eat crap food all the time. You have to have terrible sleep. Make sure you never unask the couch, sit in front of the TV all day, look at doom scrolling, do all that kind of stuff. Make sure you never exercise, and make sure you don't have any friends or be happy. He says, you're on the fast track for not only cancer, but all these other chronic diseases. So that's what I just said is you need to not do that. You're doing a great job. There's not many people are going to be measuring their GKI every day, but there are people who love to measure that kind of stuff. Now, I tell you another thing. So they put these things on your arm, these continuous sugar monitors. They're making continuous glucose ketone monitors. So apps are coming out now, believe me. There's apps. I have my Lucas Liu and some others are making these apps in my lab, and you can take your cell phone and photograph a particular food item, and the food item immediately places the food item on the chart, so you'll know eating that will give you what zone you'll be in if you eat it. So it's really interesting, and these things are coming. We're using AI but it's purely patient empowerment, okay? The patient themselves, the person themselves make the choices. No government, president or king or whatever you want to say, should ever tell people what and how they should eat. The patients should be familiar with this and have the knowledge to know, I'm going to test what I think. So people say to me all the time, just tell us what you can eat. That's all they say to me. Okay, eat whatever you want. You figure out where on the chart you're going to be, and then you'll know. So people say, well, I can't eat ketogenic diet. Well, our group in Greece, now you tell me, they got the brain cancer, tremendous success in keeping brain glioblastoma guys alive. What was the diet? It was a calorie-restricted Mediterranean diet. Salmon, sardines, olive oil, avocado, and exercise. Is that like, oh man, that's the worst diet. What about the carnivore diet? What about the ribeye with a little sauce béarnaise on top of it? This keeps your blood sugar low and elevates your ketone. If you want to do it with plants, everything, you got fish, plants, you get the vegans and all these kind of people. This is a bioenergetic roadmap to health.
Let me just give some specifics. So,
and this is amazing.
What about high fructose corn syrups and refined sugar?
Man, that's the worst kind of crap. You don't take that.
What about industrial seed oils?
Well, people talk about seed oils,
canola and soybean.
Yeah, I don't know. And listen, another thing too. You and I are different. We have an individual metabolism, age, race, sex, all the religion, all kinds of stuff determine what and how you live. And I can't be sure what you eat and what I eat or what you exercise, where it's going to put us on the chart.
Synthetic pesticides. I was reading here that it increases the chance of lymphoma by a staggering 41%.
They all damage the oxidative phosphorylation, putting the cell at risk for compensatory fermentation, dysregulated cell growth. Wow. The problem, the field doesn't understand what I'm saying with respect to the origin of cancer, how it happens mechanistically, how this organelle controls the life of the cell. They don't know enough about the biology and biochemistry of the mitochondria. You want to get guys on here like Nick Lane, he from England. I mean, these guys like Doug Wallace and some of these guys, they're mitochondrial biologists. They understand this kind of stuff.
I want to give people actionable things that they can think about. So that's why I was asking you this question about you becoming king. Fasting protocols.
Well,
what do you think
okay.
of intermittent fasting?
Let me talk about that just briefly. Did you ever try it?
Yeah.
What do you think? You liked it?
It depends how long you're talking about.
Okay, let's go a week.
Oh, no, I've not fasted for a week before.
Okay. You know what is the call of the wall? This guy, he just sent me his book. It's coming out. A very nice guy, Viral Simak. People share things with me. The wall is after about 3 days of not eating, just drinking water, you hit this wall and it's like, oh man, I can't deal with it anymore. It's just a terrible feeling in my body. I can't sleep at night. I got the Jimmy legs. I got all kinds of problems. Screw it. I'm not doing this. He found out if you sip just tiny amounts of a grape juice, you can get through the wall. What we do for the cancer patients in the way we design our clinical procedures, which my clinical friends, we do a zero carb diet for about a week while the body is readjusting, bringing them out of the red zone, getting into the yellow zone. You can't believe the power of glucose as an addictive drug on the brain. It's unbelievable. It's like cocaine. And you know that when you start shaking and you're going. So, but if you don't eat carbs and just eat meat or whatever to keep you in a low GKI, Then when you jump off to the water-only fasting, it's much less traumatic to the brain. You've gone through the wall, the gate, so to speak. So once you know how to get through the gate, you make this whole process a lot easier. And that helps people enormously, especially those people that want to get rid of their chronic disease, okay? Because, or some, we have a lot of people out there that just like to do all this stuff. You ever get these people that go overboard on everything. But, right now we have an obesity, chronic disease, cancer epidemic. All of these epidemics are the result of an abuse of that organelle in one way or another. And we have a plan to mitigate that abuse. And at least people at least they're empowered to do it with the help of knowledgeable physicians.
I want to just keep on this point of actionable feedback. So Dr. Walter Longo's, his extensive research clinical trials prove that fasting mimicking diets drastically lower IGF-1, which triggers cellular autophagy and actually makes standard cancer therapies up to 3 times more effective by removing the metabolic shield of cancer cells.
Yeah, which is the waste products of glucose, which is the lactic acid and the succinic acid. That all goes down.
Would you recommend, again, if you're king, would you recommend that
I would never recommend any. I have to just give them the knowledge. Then the person has to make the decision themselves.
Do you think it could be beneficial?
Of course.
If you were king, to have everybody wear a CGM, one of those continuous glucose monitors, at least once?
No.
Never?
No, I think if you have cancer and you really want to stay in this green zone to know, right? Listen, I was down in Mexico not long ago. I was talking to one of the head physicians down there. He wore one of these things, right? Mm-hmm. He said, every time I wanted to go out and have a party, have a good time, this damn thing would be beeping. So what do you, ripped it off and threw it in the trash. So you don't want somebody barking in your ear when you're having a good time. That's why what you're doing right now with this, you're choosing to prick your finger. You're the one making that decision. There's not something on your arm saying, Stephen, don't do that, don't do that.
But you know what? It was useful to wear it once or twice.
Yeah.
Because it even, I suddenly realized that things I put in my mouth had an impact on my blood sugar, on my blood, and also I realized that it had an impact in 10 minutes.
Yeah. Oh, fast.
And then also when my blood sugar came back down and crashed, I thought, oh gosh, I could suddenly pair my behavior to my feelings.
Yes. Well, now I've seen that, and not only that, Andrew Scarborough from England, who's been doing this for either stage 3 glioma, he's like 15 years out. He's done this so many times with the finger prick and all this. He knows now already when his body is in these zones from the feeling that you just described. But for the people at the beginning and who are given a terminal diagnosis, they want to get into these green zones and they want to use the things that are going to keep them alive on the planet for a longer period of time with a higher quality of life. That is important. That thing on your arm can help you stay in that zone until you have this thing managed, at which time you can choose when to do that. So this flexibility in this whole process, it's not one, like for example, we have the standard of care, which is written in granite, for crying out loud. If you do anything different from the standard of care, you could lose your license as a physician. Metabolic therapy is patient driven. It's driven on the patient.
What about hyperbaric oxygen?
Yeah.
There was a study in 2013 that demonstrated that while a ketogenic diet alone significantly slowed tumor growth in systemic metastatic cancer mouse models, combining the diet with hyperbaric oxygen therapy elicited a profound synergetic decrease in tumor growth and drastically increased survival times.
Yeah, we published that paper with Dominic D'Agostino. So listen, hyperbaric oxygen will create oxidative stress in cells that do not have efficient oxidative phosphorylation.
Cancer cells.
Cancer cells. So you can kill cancer cells by oxidative stress by irradiating or poisoning them, or you can put a patient in nutritional ketosis and then put them in hyperbaric oxygen, and the cancer cells are selectively killed. When you irradiate somebody, you're damaging the whole body with all kinds of stuff. And there's another thing, Stephen, you got to listen to this, and you listen carefully. When you go to treat these standard of care, when you use standard of care, radiation, chemo, whatever they give you, immunotherapies or whatever. So the patient comes in and he says, I've been really working hard on this. The doctor says, oh, no, that doesn't work, right? Gives you some radiation or gives you flying up into the red zone. The treatment itself puts so much stress on the body that the body itself starts going, you go into the red zone from the very treatments that you're giving to the patient, which is strengthening the tumor cells.
You're not against chemotherapy though, are you?
No. I'm positive about it, but it has to be used in the right context.
Yeah.
It has to be used when your body is in this state of nutrition. And you can use low doses so you don't force the tumor cell to become even more resistant to the treatment.
The next thing, which is actionable, is what you talked about earlier, which is these microplastics and forever chemicals. In late 2023, the International Agency of Research on Cancer officially upgraded these forever chemicals, which are used in non-stick pans and food packaging, to a grade 1 carcinogen in humans, cancer-causing in humans, based on strong mechanistic evidence that it induces epigenetic, which is gene alterations, and suppresses the immune system. So you ban the forever chemicals.
Okay, this is a beautiful paper. I went back and I took what all of Otto Warburg meticulously went through all of his work, showed where he was absolutely correct and where he just didn't have the new information that would make him. I talked about the forever chemicals, microplastics. Guess what? They damage the organelle. They get into, they break, they cause rust and damage. It reduced the efficiency of oxidative phosphorylation, causing a compensatory increase in the utilization of glucose and glutamine and dysregulated cell growth. Everything comes back to this organelle. All chronic diseases and cancer are the result of damage to this organelle. That's why having this little thing here is so important. It's a great prop. I ought to get one for my class.
You can keep it. The next thing is purifying the water supply. Heavy metals are found in local water supplies to run off and ultimately are carcinogenic in some cases. The IARC classifies arsenic and cadmium as group 1 carcinogenics, and they're frequently found in unfiltered public water infrastructure. So you clean out the water supply as well.
Yeah. You know, all this stuff is coming into our water supplies, people flushing down all these chemicals into the which then leach back into the water supply. And every one of the chemicals that we have looked at that has been linked to oncology or dysregulated cell growth all damage the oxidative phosphorylation chronically. So we're bringing the entire focus back to things, what can I do to keep this organelle healthy, even if I'm exposed to these chemicals, if I can get into these zones like you're trying to do. So even if you are exposed to these, this organelle has an incredible healing power in itself.
What is the most important thing we haven't talked about that we should have talked about, Professor Thomas?
Well, I mean, you've covered a lot. One of the things I want to talk about is metastasis.
What's that?
That's the spread of the tumor throughout the body. Okay. So if you were to have a cancer that's just localized in one spot, you know, the probability of developing a therapy that would be long-term is highly increased. The problem that kills people is the spread. So if the tumor is in the breast and it spreads to the liver and the lungs and the brain, you know, you've got a problem. Lung cancer spreads to the brain, the liver. Most of these cancers that spread to the brain or other organs become difficult, and that's why you use systemic chemotherapy. You're trying to stop. What we have found is that you have a stem cell. People love stem cells. If you ever hear the term stem cell tumor, wow, stem cell tumor. Stem cell tumors cannot metastasize. How do I know? Because I have stem cell tumors diagnosed as stem cell tumors with stem cell markers. I've grown them. They grow very angry. They get a lot of blood vessels, but they can't spread. Okay. How do you get spreading tumor cells in your body? The immune system comes in, recognizes that as an unhealed wound, and then fuses with the stem cells. And then you have these hybrid cells. They are programmed to move around your body. So they are a macrophage tumor cell hybrid. So, and they're very hard to kill. But we found they're remarkably sensitive. They're glutamine driven. So we know they're glutamine driven and they need the glucose. And that's why metabolic therapy done the right way can nail those metastatic cancer cells, purging them with a little bit of immunotherapy to go along with it. You might be able to get what we call resolution. Don't forget, my colleagues and I, Dom D'Agostino, Joe Maroon, we built the press pulse therapeutic strategy. I mentioned that on your previous show. That's the way you press down the glucose of the tumor, and then you pulse to kill the glutamine, which will target the metastatic cancer cells, enhancing the health and vitality of the organs already infiltrated by the tumor.
I looked on our previous conversation, Professor Thomas, and it's quite heartbreaking because the comments sections are all people that are either struggling themselves with cancer or a loved one of theirs, their wife, their husband has just been diagnosed with cancer. Is there anything for those people that have clicked on this video? Because I imagine they are in the millions.
Yeah.
That
Millions.
you want them to hear.
Well, the thing of it is why, well, this is a bigger issue. When you have the science and you have the strategy to manage cancer effectively with minimal toxicity, not to say we can cure, but to say we can manage it, why is it not being done? That's the question.
But to them who've tuned in.
Okay. So these kinds of conversations that we have are allowing the populations to realize that their loved ones do not need to be sacrificed for the good of industries that are generally considered profitable. In other words, the profitability of the industries are based on your sickness. And a lot of those comments came, oh, you can't do anything. Yes, you can do something about it. When you're armed with the knowledge and people ignore the knowledge, then there's a problem.
Do people need to sort of self-advocate to some degree?
I think so.
With care providers? What do they?
Yeah, I think that's a very delicate question.
Yeah.
The oncologists never heard of this stuff. They have never read these papers. They were never trained in medical school to know the biology and biochemistry of cancer. It was told to be a genetic disease. Theories are so important in science. For 1,800 years, people thought the work of Aristotle, his comments, and the mathematics of Claudius Ptolemy said that the Earth was the center of the solar system and all the planets and sun revolved around the Earth, the geocentric theory, right? Copernicus struggled with the Ptolemy mathematics and realized that if he put the sun in the center of the solar system and made Earth just another planet, a lot of the mathematics made sense. Kepler comes in and says, these aren't circles, they're ellipticals. Galileo takes the telescope, sees the moons of Jupiter, and was able to look at and quantify predict where planets would be at a certain period of time. Then they took poor Giordano Bruno. You know about this guy, Bruno? Oh, Stephen, you got to know Bruno. Your job is to know about the poor Bruno, who was burned alive by the Catholic Church for challenging the geocentric theory, and he became a martyr of science. So when you have established power structure, whether it's a religion or whether it's an industry or whatever, challenging that can be very, very hazardous.
Has it been hazardous for you?
No. I mean, I do what I do because I just collect more and more data to support. Hazardous for me would be getting blindsided. Blindsided would be somebody coming at me with a piece of new data that I have never considered. I don't sleep. I think about this stuff all the time to avoid the blind side. My students are on the alert for any paper that comes out that says cancer cells can burn fatty acids and ketone bodies. Oh, really? Let's go back through and dissect out their control experiments. And you find that every case there was always some glucose and glutamine in the media, making it look like the fatty acids. So that's what bothers me. What bothers me is getting hit with a piece of data that undermines what our knowledge base is. And so far, we haven't had that. Okay, we're standing on the shoulders of Otto Warburg, a giant in the field of biochemistry. He was thrown under the bus when everybody thought cancer was a genetic disease. This paper goes back and shows exactly where Warburg made his mistakes and where we have rectified some of that, bringing the whole field back on where it should be. It is a mitochondrial metabolic disorder, and we can account for all of the phenotypes and characteristics of that disease knowing that. Now, with that knowledge, logical people and people interested in helping others will take advantage of that. We're not throwing out all these toxic chemicals. We're learning how to use them in a different way. And that's where the success is going to come.
So let's conclude with a actionable takeaway for people who are suffering themselves with cancers, or have someone in their family right now that is suffering from cancers. What is the actionable takeaway? Well,
I think the actionable takeaway, once this paper comes out, they can start taking action if they are motivated enough.
They can read about this.
They can read about it and then try to, just like you're doing, different, get into these zones and then work with their oncologists, knowledgeable people, to treat them with standards of care as long as they can remain. And then we do non-invasive imaging, PET scans, MRIs.
Okay, so specifically what you're saying is this paper, I will link it below in the comment section for anyone that wants to read it. This graph will be on the screen throughout this episode anyway, so people can screenshot it if they want to have a look. And the way that they test what their GKI index is they can buy one of these Keto Mojo things, which you can get on Amazon for $20, $30. You prick your finger, it gives you the glucose reading.
Yeah.
You divide it by 18.
No, the new machines have the button. So even the people don't have to do that.
Okay, fine. And yeah, as you can see on here, this is an interesting way to sort of increase your management, improve your management of some of these.
Yeah, and then there's a challenge to get into those zones. I'm not saying this is easy stuff. GLP-1 inhibitor, man, that's a hell of a lot easier than doing this.
And I should probably say, always consult with a medical professional.
Yeah, I think because, a lot of people, they have a lot of comorbidities. They have diabetes, high blood pressure, hypertension, cancer. It's not a perfectly healthy person with cancer.
Mm-hmm.
So before you go in to challenge that, you need to have what you look like. You might look, you might have to be adjusted in some way.
Yeah,
that's why the physicians that are working with this can do all that. I'm not in the clinical thing.
And there are some people who respond poorly to the ketogenic diet and it's high states of ketosis, because I've received DMs before from a woman who said, my husband did ketosis and he collapsed unconscious. He took him to the hospital. He had some comorbidity.
Yeah. The other thing too is some people have carnitine deficiencies. Carnitine prevents fatty acids from being made into ketone bodies. So they can be, carnitine supplementation can help them. But you need a physician to know this.
We have a closing tradition where the last guest leaves a question for the next. And the question left for you is on the subject of energy. What in your life has brought you the most energy? And what was the biggest energy drain you've ever experienced?
This is bringing me the biggest energy.
This.
Well, not this, the whole concept. The idea that you have found Mother Nature has allowed you to look into the depths of what we consider the biology and biochemistry of how bodies work, and knowing how to take that and apply it to people that are suffering from all these different chronic diseases and giving them the opportunity to change that. Because before that, it was mysterious. Oh, I'm in keto. What's your GK? I don't know. Well, now you have a quantitative opportunity. That gets us. So we have a lot of evidence. I think people should feel encouraged. I think we have given hope to the hopeless. And I think that's empowering. And the goal here is not to make $1 billion. It's just to know that you've kept all these poor souls alive longer than they were projected to be. And I think there's power in that. And that keeps us going. Because when we see more and more people coming to me, I get emails back from people 3 or 4 years ago. And I said, gee, I thought you were a goner. And he says, oh, I'm doing really well. Just came back from a vacation with my wife. Well, that's empowering. I said, well, that's good. And don't forget, Stephen, all of our research money comes from private foundations and philanthropy. So
is that a way that people can help?
Yeah.
And where do they go to help?
Travis Christofferson's foundation. So in my papers, we have the foundations that support our work, private foundations.
So I'll link
and there are occasionally, yes, please link. There are occasionally people, I know, when I give kits of information to people, I say, please consider making a donation only if it works for you.
Yeah. Don't
charge them anything or ask them to pay something if it's not going to help them. If you were told to be dead in 6 months and 6 years later you're alive, maybe you throw us a few shekels into the into the foundation supporting our work.
I'll link that foundation below in the comments section.
Yeah, we have a couple on breast cancer, on general support on the metabolic approach that we have. So we have a lot going. We're very excited. You can see all the papers we've published. And it's not like some of these are in top journals. Some of them are in new journals. But the issue is we're publishing this.
My thing is, I great respect for science and doctors and the medical profession. Go get your information. Speak to your medical provider. There's so many tools out there now. Go and check for yourself.
Yeah, well, I think in the oncology field, that's where we have this vast wasteland of misinformation or misunderstanding. Let's put it that way. They don't understand these concepts where, people who have done heart work and bone work and replacements, those people are at the state of the art with this kind of stuff.
Well, the last conversation we had, it's reached about 15 million people. So on YouTube, it's got 10 million views. And then across audio platforms, it's got another 5 or so million views.
Yeah.
And when I read through the comment sections, it's so heartening for 2 reasons. One is you're giving people tools and science that they can think about and research themselves and speak to their medical practitioner about, but also it actually just creates a community of people in the comment section where, this is a community of people that are searching for hope.
Yeah.
And as some of them read through the comment sections, they actually commented saying it was so nice to speak to other people in the comment sections about what I'm going through and how it feels from an emotional level. So this is something I actually wanted to say in this episode was, if you're listening to this conversation now and you've gotten to this point, do feel free to go into the comment section and just offer some support and some love to other people who are struggling, because, it can be a very lonely experience the minute you find out you've got a diagnosis and off you go into the internet, into podcasts, into AI to try and figure out what you can do. So yeah, do share things that have helped you, point at different resources that are rigorous, and offer emotional support to those that are in the comment section. That would be a wonderful thing. Thomas, thank you so much for all that you do. You're an absolute warrior for pushing the science into the world, and for fighting for these people that don't have the tools. And I don't think I've ever seen a comment section quite like it in terms of the gratitude that people have for the work that you're doing. It is remarkable work. Long may you continue to do it.
Thank you very much. And you play a very important part on this, because this information is not disseminated to the population. And it's the population of people that will eventually make the change. So they're going to want this, especially when we keep publishing more and more case reports of successful cases. And the system will change. And we just have to modify what we have to make it better. And I think that's what keeps us going. So I have no plans of stopping this anytime soon. My students are all excited about this. They're learning about it at Boston College. So this is a big emphasis that we have, and we continue to do it. And again, scientific literacy is so important for how you navigate through life. And thank you very much for your show, and we'll keep pushing this as hard as we can.
Thank you.
YouTube have this new crazy algorithm where they know exactly what video you would like to watch next based on AI and all of your viewing behavior. And the algorithm says that this video is the perfect video for you. It's different for everybody looking right now. Check this video out, and I bet you might love it.